All right, today we are doing trigonometry. We are focusing on angle of elevation and angle of depression problems. We call them 2D problems. All right, it says RQ, it's a vertical pole. So we have got RQ. Now the foot of the pole Q, it's on the same horizontal plane as P and S. So we've got P and S. The pole is anchored with wire cables RS. So this is RS like this. And RP. So we also have RP. The angle of depression from the top of the pole to P is 47 degrees. Angle of depression. So this is the angle. All right. This is the angle which is 47 degrees. PR is 21 meter, so the length of PR here is 21 meter, and QS is 17 meter. So we have got QS, which is 17 meter, so this is QS, 17 meter. And then we are told that RPQ is equal to theta. So we have got this angle, that is RPQ. All right. Question number 1, which is 6.1. Write down the size of angle theta. Now 6.1. Angle theta is given by, so we will just say theta is equal to, now there's something that you have to notice here. This line, do you see this line here? That line there, it's horizontal, and even this one is horizontal. So these two lines, they are parallel to each other, but it is not indicated for you to know that they are parallel. It's something that you have to keep in mind, that if that one is horizontal and this one is also horizontal, therefore these two lines, they are what? They are parallel. So in this case, that means since we are having angle which is equal to 47 degrees there, that means even this one is going to be equal to 47 degrees. Reason, so that will be what? 47 degrees there. So the reason will be what? Alternate angles, right? Good. So just because we have got these two lines that are parallel, okay? Parallel lines. All right, so you can give your answer like that. 6.2, it says calculate the length of RQ. So we need to find RQ. This is RQ, right? So we need to find RQ. Okay, so now in order for us to find RQ, we already have what? Angle theta here, which is what? 47 degrees. So with reference to this angle, right? Angle P, this side is the opposite side. This one is the opposite side. And that is the hypotenuse there. So which ratio is that? That is what? That is sine. So 6.2, we will say sine P is equal to RQ, is equal to RQ divided by what? By RP. Divided by RP. Right, now sine, we do substitution now. We do substitution now. Now where there's P, we are going to write what? 47. And we are looking for RQ, right? So we write RQ. And that is divided by RP. The value of RP is equal to what? 21. So we write 21. Now in this case, what we have to do is just to cross multiply, right? So we will have 1 multiplied by RQ. So that will give us what? RQ. And then when we cross multiply, we will have sine 47 degrees multiplied by 21. So we will have 21 sine 47 degrees, right? Now when we press our calculator, RQ is equal to 15,36 meters. All right, so that becomes the answer there. Now 6.3, they say hence calculate the size of S, right? Once they say hence, they are saying from your previous answer, right? So we have to also use this one when we are calculating. So we need to find the size of what? Angle S. So this is the one that we are looking for right there. So what we need to do here, if we are using this angle S as our reference, right? This side is the opposite side. That side right there is the adjacent side. So the ratio we are going to use will be opposite over adjacent, and that is tan. So we will be able to say 6.3, and then we say tan S, right, is equal to RQ. RQ is this line, right? That is RQ divided by QS. So we have to divide by QS. Now what we do, we just do substitution, right? So we will say tan S like this is equal to, what is RQ? RQ is 15,36 divided by QS, which is 17 meters, right? Now, because we are looking for S, right? We are looking for that angle. We will say angle S is equal to, we take the inverse of what? Of tan. Open the brackets, we write 15 over 36 divided by what? By 17. All right, and then we say angle S is equal to, now we need to press our calculator for this to get the answer. Right, so after pressing my calculator, I get 42,10. So that is the angle there, but it must be in what? In degrees. All right, so this is the answer that we get. 6.4. If P, Q, and S lie in a straight line, how far apart are the anchors of the wire cables? All right, so we need to find the length of what? Of PS. We already have the length of what? Of QS, but we do not have the length of PQ. So we need to find the length of PQ, and of which that is going to be easy. What we can do, we will use this side, which is the adjacent side, and the hypotenuse side there. So we can use cos to find the length of what? Of PQ. So let us do that. So we will say cos P is equal to the adjacent side here, that is what? That is PQ, the one that we are looking for, right? Divided by RP, divided by RP. Now this will give us cos 47 degrees is equal to PQ divided by what? By 21. So we will have 21 there. All right, that is over 1. So we need to cross multiply. Now when we cross multiply, this is what will happen. Okay, so we will have 1 multiplied by PQ, so we will have PQ, and then now we will have 21 multiplied by cos 47, so that will be 21 multiplied by what? Cos 47 degrees. Then the value of PQ, when we have to press a calculator in order for us to get the value there. Okay, so the value that I get after pressing the calculator is 14,32 meters, right? So this is not our final answer. We just have to add what we get here, because here we have got 14,32, right? So we just have to add with 17 to get our final answer. So we will say therefore PS is given by PQ plus QS, right? Now what is PQ? PQ is 14,32. Now what is QS? QS is 17 meters, right? And then the final answer, I will say therefore PS, right, is equal to, we just have to press our calculator. All right, so that will give me 31,32 meters. All right, and right there, that is our answer. Thank you guys. Thank you for your time. Take care.